We are about to embark on a journey of scale so immense, it will fundamentally change how you see the night sky. For millennia, human beings have looked up and seen stars, constellations, the dusty band of our own Milky Way. But there is one object, visible to the naked eye, that is not a star at all. It is a gateway, a porthole into an ocean of reality so vast, our minds instinctively shrink from it. Tonight, we are going to step through that porthole. We are going to visit the Andromeda Galaxy. This is not just an astronomy lesson. This is an exercise in cosmic perspective. We will start with what you can see from your backyard, and from there, we will expand, layer by layer, fact by fact, until the true majesty of this island universe comes into focus. By the end, that faint fuzzy patch will be transformed. It will become a place. Let's find it. On a clear, dark night, far from city lights, look for the constellation Cassiopeia, that distinctive W or M of stars. Imagine a line starting from the central point of that W and shooting like an arrow towards the great square of Pegasus. About halfway along that arrow, you will see it. A soft, elongated smudge of light. To the ancients, it was a curious cloud. To us, with our unaided eyes, it appears about as wide as 3 full moons laid end to end. But that is a lie. A beautiful, cosmic lie. Your eyes are only seeing the bright, central hub, the galactic downtown. In reality, with long-exposure photography, the full disk of Andromeda stretches across an area of sky equivalent to 10 or 12 full moons. It is, in fact, the single largest deep sky object visible without a telescope. We are seeing only the tip of the iceberg, and the iceberg is a continent. The first crucial step in understanding Andromeda is to internalize not just its size, but its distance. The light hitting your retina tonight left that galaxy 2.54 million years ago. Let's break down what that number means. Light is the fastest thing in the universe. It travels about 300,000 kilometers in a single second. In 1 year, it covers a distance so vast we call it a light year, roughly 9.5 trillion kilometers. Now, multiply that by 2.54 million. The distance to Andromeda is approximately 24 quintillion kilometers, a 24 followed by 18 zeros. To grasp this, consider a cosmic chase. If you could board a ship that travels at the speed of light itself, the absolute speed limit of the universe, you would not arrive at Andromeda for 2.5 million years. You would pass by the ruins of human civilization, watching millennia flicker past in an instant, and still have an eternity to travel. Our fastest human-made object, the Parker Solar Probe, would take nearly 4 billion years, almost the entire age of our planet. That light travel time is a time machine. When you look at Andromeda, you are not seeing it as it is now. You are seeing it as it was when early human ancestors, Homo habilis, were first crafting stone tools on the African savanna. The entire tapestry of human history, the pyramids, Rome, the Renaissance, everything, occupies less than 1/4% of the time that light has been in transit. You are gazing into a profound, deep past. For most of history, we had no idea what we were looking at. It was cataloged as a nebula, presumed to be a glowing cloud within our own galaxy. The revelation came in the 1920s, thanks to Edwin Hubble and the powerful 100-inch telescope at Mount Wilson. He was able to resolve not just a cloud, but individual stars within that fuzzy patch. And not just any stars, he found Cepheid variables. These are special stars that pulse with a regular rhythm, and crucially, the period of their pulse is directly tied to their true, intrinsic brightness. It's like finding a 100-watt light bulb in the distance. If you know it's a 100-watt bulb, and you measure how dim it looks, you can calculate exactly how far away it must be. When Hubble applied this standard candle, the result was earth-shattering. Andromeda was nearly 1 million light-years away, far, far beyond the known boundaries of the Milky Way. That faint smudge was not a cloud in our attic. It was an entire, separate city of stars. In an instant, the universe expanded from being our single galaxy to a universe filled with galaxies. Ours was not special. It was one of many. So what is this other city? Andromeda is a barred spiral galaxy, a sibling to our own Milky Way, but an older, larger sibling. Its spiral disk stretches about 220,000 light-years from edge to edge. To cross it at light speed would take 220,000 years, 5 times longer than Homo sapiens has walked the Earth. Within this volume resides an almost inconceivable number of stars, roughly 1 trillion. For comparison, our Milky Way holds between 100 and 400 billion. If you tried to count the stars in Andromeda at a rate of 1 per second, without stopping, it would take you over 30,000 years. The sheer quantity is numbing. Let's take a tour from the inside out. At the very center lies a supermassive black hole named M31, with a mass of about 140 million suns. Imagine our sun. Now imagine 140 million of them crushed into an infinitesimal point, creating a gravitational vortex so strong that not even light can escape. For comparison, the black hole at the center of our Milky Way, Sagittarius A, is a mere 4 million solar masses. Andromeda's heart is over 35 times heavier. It is currently quiescent, a sleeping giant. But should a star or a massive gas cloud wander too close, the black hole would awaken. Tidal forces would stretch the star into a spaghetti-like strand of superheated gas in a tidal disruption event. As this material spirals in, it would form a blazing accretion disk, potentially transforming the galactic core into a brilliant quasar, outshining the rest of the galaxy combined. Surrounding this dark heart is the galactic bulge, a dense, spherical swarm of ancient stars. These are population 2 stars, old and metal-poor, glowing with a reddish hue. They are packed so densely that if you stood on a hypothetical planet near the core, your night sky would never be dark. Thousands of stars would shine brightly enough to cast shadows, creating a permanent, starry twilight. Spiraling out from this bright core are the grand, sweeping arms. These are not solid structures, but density waves, like a cosmic traffic jam. As stars and gas orbit the center, they move in and out of these regions of higher density. It is within these spiral arms that the galaxy comes alive with creation. Here, we find vast molecular clouds, cold, dark nebulae hundreds of light-years wide, composed of gas and dust. When the density wave passes through, it compresses these clouds. Gravity takes over, causing the cloud to fragment and collapse. In these stellar nurseries, new stars are born. The most massive of these newborns are brilliant blue O and B-type stars. They live fast and die young, burning through their fuel in only a few million years before exploding as supernovae. These explosions are cosmic forges, blasting space with heavy elements like carbon, oxygen, and iron, the very elements that make up planets and life. The spiral arms appear bright and blue because they are lit by these stellar fireworks and nurseries. The stars and gas are arranged in a remarkably flat disk, only about 1,000 light-years thick. This disk rotates, but not like a solid wheel. Stars closer to the center complete an orbit in tens of millions of years, while those in the far outskirts take over 1 billion years. By measuring the orbital speeds of stars at different distances, astronomers uncovered a profound mystery. The stars in the outer regions are moving far too quickly. Based on the gravitational pull of all the visible stars and gas we can see, they should be moving more slowly and flying off into space. The only explanation is that there is vastly more invisible matter providing extra gravity. This is dark matter. Andromeda, like all large galaxies, is embedded in a gigantic, spherical halo of this mysterious substance. For every kilogram of normal matter, stars, gas, you and me, there are about 6 kilograms of dark matter. We don't know what it is. It doesn't emit, absorb, or reflect light. But its gravitational grip is what holds the entire galaxy together. The visible galaxy is just the luminous ornament on a hidden, massive framework. Beyond the bright disk lies the extended stellar halo, a vast, sparse sphere of old stars and globular clusters. This halo tells a violent history. It is strewn with faint rivers of stars called stellar streams. These are the remnants of dwarf galaxies that ventured too close to Andromeda and were torn apart by its tidal gravity. Andromeda is a cannibal. It grows by consuming its smaller neighbors. Its two most famous satellite galaxies, Messier 32 and Messier 110, are currently being digested. M32, a compact elliptical, orbits perilously close and is having its outer stars stripped away. In a few billion years, it will be completely absorbed. This is a standard process in cosmic evolution. The big get bigger. Evidence suggests Andromeda had a particularly dramatic meal about 800 million years ago, a major merger with another large galaxy. This collision is likely responsible for the galaxy's slight asymmetry and a spectacular ring of intense star formation that circles the core. It's a scar from a past battle, still healing. Andromeda is not a static painting. It is a dynamic, evolving system. And its most significant future interaction involves us. The Milky Way and Andromeda are gravitationally bound in a slow cosmic dance. Right now, we are rushing toward each other at about 110 kilometers per second, roughly 400,000 kilometers per hour. Despite this blistering speed, the distance is so vast that the collision is still 4.5 billion years in the future. What will happen? The word collision is misleading. Space is overwhelmingly empty. The stars themselves will almost never physically hit each other. Instead, the galaxies will pass through each other, their gravitational forces acting as immense tidal hands. During the first close pass, the orderly spiral structures will be shredded. Long, beautiful tails of stars will be pulled out into intergalactic space. The real action will be in the gas. When the giant gas clouds from both galaxies slam together, they will compress, triggering a frenzy of new star formation, a starburst that will light up the merging galaxies. They will then swing apart, only to be pulled back together by gravity, merging again over a billion-year-long ballet. Finally, they will settle into a single, giant, elliptical galaxy that astronomers have playfully dubbed Milkdromeda. The two supermassive black holes will spiral together and merge, releasing a phenomenal burst of gravitational waves, ripples in the fabric of space-time itself. By this time, our sun will be entering its red giant phase, likely rendering Earth uninhabitable. But if any descendants are around to see it, the night sky will be a spectacle beyond comprehension, two galaxies becoming one. Everything we know comes from dissecting the light that reaches us. We study Andromeda across the entire electromagnetic spectrum. Radio waves reveal the distribution of cold hydrogen gas. Infrared light pierces dust clouds to show hidden star formation. Visible light shows us the stars themselves. Ultraviolet highlights the hottest, youngest stars. X-rays pinpoint the violent regions around black holes and supernova remnants. Each wavelength is a different sense, allowing us to build a complete portrait. Yet for all we see, there is infinitely more we cannot. We cannot resolve a single planet orbiting any of its trillion stars. We cannot search for biosignatures, signs of life, in alien atmospheres. We cannot know if, among its countless worlds, oceans shimmer, mountains rise, or minds contemplate the cosmos. Given the sheer numbers, it is statistically almost certain that simple life exists somewhere in Andromeda. But intelligent, technological life? A civilization looking back at the Milky Way as a faint smudge? That is one of the universe's greatest mysteries. The distance creates an unbridgeable gulf. Any signal we might send would take 2.5 million years to arrive. A reply would take another 2.5 million years to return. We are, in a very real sense, cosmically isolated. And so, we return to where we began. A human being, under a dark sky, looking at a faint smudge. But now you know. That smudge is a trillion suns. It is a history of collisions and a future of merging. It is a gravitational empire with a dark heart and cannibalistic habits. It is a collection of stellar nurseries and graveyards, forging the elements of life across incomprehensible volumes of space. The true scale of Andromeda is not just in its measurements. It is in the perspective it forces upon us. We are fleeting. We are tiny. Our world is a speck. And yet, we have figured this out. With minds evolved to track prey and build shelters, we have measured the distance to another galaxy. We have mapped its structure across millions of light years. We have deduced its past and predicted its future. In the face of such overwhelming scale, we have not been rendered silent. We have been inspired to understand. That is the ultimate wonder. The universe is vast, ancient, and filled with grandeur beyond our physical reach. But it is not beyond our comprehension. When you look at that faint patch in Andromeda tonight, you are not just seeing light. You are seeing a mirror held up to our own curiosity, our own ingenuity, and our profound, beautiful desire to know our place in the cosmos. That light has traveled for millions of years through the cold void to reach you. And in seeing it and understanding it, you complete its journey.